Welcome to another video in the Visual COBOL for Eclipse in a Nutshell series. In this video, we'll explore moving from Server Express to Visual COBOL. Let's quickly review what you'll learn in this video. I'll explain some concepts and best practices for migrating an application from Server Express to Visual COBOL. We'll explore reviewing your Server Express application to identify some of its key components, including source code and compile settings. How you can use Visual COBOL at the command line, executing the same commands you know from Server Express. Finally, we'll take a look at how you can bring your application into the Visual COBOL IDE to take advantage of the new productivity features in this state-of-the-art development environment. As part of this exploration, I'll demonstrate an example of moving a COBOL application, originally developed in Server Express, into Visual COBOL. Before we start, let's quickly cover some assumptions and prerequisites. This presentation assumes you are already familiar with Server Express and are familiar with your application and its configuration and settings used at compile and runtime. Also, the information presented here assumes you have already installed and licensed the Visual COBOL products. For information about installing and licensing, as well as more detailed information about using Visual COBOL for Eclipse, please search for the Micro Focus playlist, Visual COBOL for Eclipse in a Nutshell, on YouTube. Finally, in this video I'll be using Visual COBOL for Eclipse 5.0. If you are using a different version, some screens may appear differently. Let's begin our review of an example Server Express application that will migrate to Visual COBOL. The source code for this application consists of a main COBOL program named locking.cbl and 4 COBOL subprograms. All of the programs use a COBOL copybook named keystat, and each of the subprograms use the statcheck and stockfd copybooks. The copybooks are stored in a separate directory. I have a shell script, build.sh, that is used to compile the programs. In this case, all of the COBOL programs are compiled to int executables. Compile directives and other compile options are specified on the cob command. We'll review these in more detail later in this video. The run.sh script sets the environment variable stock file, which contains the file spec for the data file used by this application, and then invokes the main program, locking. Let's quickly review working with this application in Server Express. I'll use the build script to compile the programs, and then use the run script to start the application. When I execute the main program under Server Express, I receive a menu where each option invokes one of the subprograms. By the way, this application is based on a set of demonstration programs provided with Server Express. I've modified the program slightly to help illustrate some of the steps and considerations when migrating to Visual COBOL. The application works with a single data file named mustock.dat. Each subprogram opens this file in a different mode. Now that we've seen the application under Server Express, let's take a look at working with it at the command line using Visual COBOL Development Hub, or DevHub for short. I also have the DevHub product installed on this Unix machine. I'll switch to another session that's configured to use DevHub. As you see, I can compile and execute the programs using the same commands. Now that we've seen that your existing commands and scripts can work as is in DevHub at the command line, let's explore how you can take advantage of some of the productivity gains provided by using the Visual COBOL for Eclipse IDE. A key initial step in moving to the Eclipse IDE is to identify the exact compile command that was being used in Server Express to compile your programs, and to identify any compiler directives in use. Rather than using a shell script as I was, you may instead be using a makefile or some other mechanism to build your application. The key thing here is to identify the actual COBOL command that is being used to compile your programs and know the options being specified. In my case, I've reviewed the shell script and have determined my compile command looks like this. The options specified with the "C" are compiler directives. There are two directives specified. The first says that these programs will receive the assignment of their physical data file names from an external source, an environment variable. The second directive instructs the compiler to look for copy files with lowercase names. Beyond directives, additional compile options may be specified using flags, such as the "-v", which instructs the compiler to be verbose in displaying messages during the compile, or the "P", which requests that a listing file be created. As we move into Eclipse, I'll show where these options can be specified. Of course, different or additional options and directives may be used at compile time in your application. Please see the product documentation for information about these items. For this demonstration, I'll be using the Visual COBOL for Eclipse IDE installed on a Windows workstation, connecting remotely to that Visual COBOL Development Hub I have installed on my Unix system. In this configuration, it's important to note that all of the source files and data files will continue to reside on the Unix machine, and the compile and execution of programs will happen there, just as they did under Server Express. Performing this type of remote development requires that a remote connection be created in the Eclipse IDE for the DevHub machine. I've confirmed that my remote connection is started. Next, I'll create a new remote COBOL project, which is going to contain my application's source code and other files. Since the files I'll use will reside on the Unix machine, I'll specify a new directory on that machine where I want my remote Eclipse project to reside. Now that the project exists, I'm going to first specify the compiler directives and settings that will be needed. In this example, these were specified in the build script under Server Express. In Eclipse, I can specify directives to be used for all of the programs in a project with property settings for that project. I'll right-click on the project, choose Properties, and then drill down to Micro Focus, Project Settings, COBOL. On the COBOL Settings page, I'll scroll down to Additional Directives and paste in my directives there. While I'm here, the lowercase v flag, which we saw on the COBOL command, can be specified with the verbose setting drop-down, changing that value to yes. Similarly, the uppercase P from the COBOL command can be specified with the generate listing file setting. Next, I'll import my Server Express programs and accompanying files into the project. To do this, I'll right-click on the project and choose Import. I see some import options, but if I choose Import again, I get the complete list of import options for Eclipse. From this, I'll choose the folder Remote Systems and then Remote File System, since the files I want to import are on the remote machine. Now I'll click Browse. In the Connection drop-down, I'll select the remote connection to DevHub I'm using within Eclipse. I'll choose to navigate from the root directory on the Unix machine, locating the directory containing my Server Express source files. The import dialog defaults to all of the files in the selected directory. I'll deselect the build and run scripts since these won't be used within Eclipse. Finally, I'll click the Finish button to complete the import. The default behavior in the Eclipse IDE is that programs are compiled, or built, as soon as they are added to the project, or whenever a change is saved. Initially, I see many build errors produced in the console view. I also see errors listed in the Problems view. If I double-click on one of these errors, the source is opened, and I'm placed on the line of source related to the error. The first error shown relates to the fact that I have not yet imported my copybooks, which were in a separate directory. I'll go ahead and do this now. For the moment, I'll import them into the same project. Once again, the project is rebuilt. This time, my project builds without error. In Visual COBOL for Eclipse, built executables are placed in a subdirectory of the project, by default named new configuration.bin. This is important to understand because when I run or debug these programs in the Eclipse IDE, that will be the present working directory, not the main project directory. Also, Eclipse will sometimes clear out the contents of this subdirectory as part of a build action, so it's best to avoid placing or creating any other files, such as data files, in this location. Another default behavior in Eclipse is that all programs in a COBOL project are compiled and linked into a single native executable file named for the Eclipse project. I can see this executable here. To instead get the programs built as individual int files, as they were in Server Express, I'll need to modify the build configuration used by this project. I'll right-click on the project, select Properties, and go to Microfocus, Build Configurations, Link. On the Link property page, I'll change the target type setting from Single Executable File to All int.gent files. Once I click Apply and Close, the project will be rebuilt with int files created for each program. Now let's try running the imported application. To be able to see the user interface as the programs run on the remote Unix machine, I'll need to have an Xserver application running on my Windows desktop, and to create a run configuration within Eclipse that will send the user interface to my Xserver. I'll run through the steps quickly here. For more information, you can see the details of this setup in the Visual COBOL for Eclipse in a Nutshell videos mentioned earlier. I'll right-click on the main program in the COBOL Explorer view and choose Run As, Run Configurations. I'll create a new run configuration of type COBOL application. I'll enter the machine name or IP address of my Windows machine that is running the Xserver, and ensure it will use the port number that the Xserver is using. The run configuration also allows me to specify any environment variables my application needs at runtime. I'll go to the Environment tab of my run configuration and add an entry for the stock file environment variable that my application needed. This was the file spec for the data file that the application uses. Since I know my programs will run from the new configuration.bin directory, I'll specify that the data file resides in the parent of that directory, which will be the main project directory. Now that my run configuration is ready, I'll click Run. I see the program's user interface in an X window and can interact with it as I normally would. I'll choose the option in the program to go into the subprogram that opens the data file in input mode and confirm that I can reach my data file. The application is running correctly in the Eclipse IDE. Now that we've seen an application brought into Eclipse, let's explore a couple of alternative configurations. We'll consider situations related to common copybooks that I'd like to use in multiple Eclipse projects, and to common subprograms which I want to be able to call from different projects. We'll also take a quick look at building our subroutines into a shared object and getting that shared object loaded by our main program. First, let's suppose that I'd like to have these copybooks available to other projects in Eclipse. Rather than duplicate them in each project, I can create a separate copybook project to hold the copybooks. To do this, I'll click on File New, Remote COBOL Copybook Project. Once again, I'll need to specify the directory on the remote machine where the copybooks will reside. Once I've done this, I can move my copybooks into this other project. Initially, this will cause compile errors in the original project, since it now doesn't know where to find its copybooks. To fix this, I'll need to add my remote copybook project as a build path in my main project. I'll go to Project Properties and navigate to Microfocus Build Path. I'll choose the Projects tab and click Add, which shows a list of the other projects in the current Eclipse workspace. I'll check my copybook project, click OK, and then close the Properties dialog. The project rebuilds, and the copybooks are successfully located. Next, let's suppose that I'd like to make the subprograms from this project common modules, so that they can be called from other projects. In this case, I'd create a second COBOL remote project and move the common subprograms there. I've created a second remote COBOL project using the same steps I followed to create the first one. I've added the same additional directives in the project settings and changed the project to create int files. Now I'll move the subprograms to the new project. This project does not know about the dependency for the copybook project, so I'll add that and get a clean compile. Finally, I'll need to tell the main project where to find the subprograms, since they're now in a different project. I do this by adding the subprogram project as a dependency of the main program project. The process is similar to what I did to add a dependency for a copybook project. As a last demo, let's say I want to simplify the deploy of my application. One option is to combine the subprograms into a single shared object, rather than deploying them as individual int files. To do this, I'll first go into the subprogram project's properties. Navigate to Microfocus, Build Configuration, Link. I'll change the target type being generated from all int.gent files to single native library file. I can change the output name to specify the name of the shared object file to be created. I'll name my shared object locksubs. In order to get the shared object loaded so that the subprograms that it contains can be called, I'll need to make a small change to the main program. I'll add simple logic to use a procedure pointer to my main program. This is done in two parts. First, define a field of type procedure pointer in working storage. Then add a set procedure pointer statement in the procedure division of the main program. The set statement with entry causes the name shared library to be loaded. This time, I'll use the Eclipse debugger to execute the program. Since I don't need any different runtime settings for debugging, I can make use of the configuration I previously built for running the program. I'll place a breakpoint on this evaluate statement, which controls which subprogram is to be invoked based on a function key pressed by the user. I'll click the Resume button on the debug toolbar, which causes the program to proceed at full speed. The program is now waiting on input from the user. In the X window, I'll press F1 to indicate I want to run the program that opens the file in input mode. Now, the debugger stops at my breakpoint. I'll step forward one statement at a time by clicking the Step Into button, and when the call statement is executed, the call succeeds and control is transferred to the stock in program. This confirms that the shared object was successfully loaded. That completes this presentation on migrating from Server Express to Visual COBOL. In this video, you've seen examples of reviewing your Server Express application, using Visual COBOL at the command line, and using the Visual COBOL for Eclipse IDE. I hope you found this presentation useful.